Clutter is the absolute bane of my existence. Having stuff scattered about has the same effect as a persistent itch that just won't go away. It's obnoxiously distracting. After nearly a year of sorting, organizing, and labeling this shop, I have more or less eliminated all the clutter from my working areas, which makes this shop a real delight to work in. But now I've spoiled myself, and I want that clean simplicity in other areas of my life. Like in a wallet. Like any good machining project, I'll need a good drawing to go by. So let's jump right into the design. There are a lot of ways this build could go, but the only real requirement will be that it must fit the dimensions of a common credit card or ID. I'm going to go for what I guess you could call a four-sided design, meaning the wallet will enclose 4 of the 6 sides of the cards, 3 edges and 1 face. So the outside dimensions will need to be a bit larger than the cards themselves to form the walls of the wallet. A holding capacity of a maximum of 5 cards should cover my needs, so that will define the depth of the card pocket and the overall thickness. To hold everything secure in the wallet, I'm going to include an integrated money clip. The springiness of the clip will keep the cards safely seated in the pocket, but also give flexibility to hold down a little cash. You know, just in case I stumble into some sort of machinist garage sale, or something. The clip will wrap around the back side of the wallet, where I'll anchor it with some 256 button head screws. I'll remove the material where the clip is mounted to bring it flush with the outside surface and keep everything looking clean. And also add a little cutout to aid in grabbing the contents. With all the functional aspects covered, I can move on to the part I've really been looking forward to. I have this whole backside that is a literal canvas just begging for some creative expression. I'd like to engrave some sort of geometric pattern on here, but I'd also like for it to be a little bit of a challenge. After quite a bit of doodling and playing around with different concepts, I've settled on whatever you would call this. I don't know what it is, but I like it. And I think I'll be able to manage the machining with some clever dimensioning and fixturing. I think. The setup I have in mind requires a fair bit of calculation ahead of time, as well as a couple changes in coordinate systems. I'll go over my thinking here when we tackle that part, but just know, it's not as bad as it looks. And since this is a project where looks will be important, material selection cannot be overlooked. I'm going to go with a 360 brass for the body and 304 stainless for the clip. I think the combination of the yellow, gray, and black of the hardware is going to look frickin' sharp, and I can't wait to get started. Actually, I don't have to wait at all. It's time to machine. Just not on the project. There are a few things I need to get in line before I can really start. Some might even call these side projects. The way I envision this going, I will be making heavy use of the rotary table. So first things first, I need to get this laid down and trammed square with the mill. I also expect to be bouncing back and forth between the rotary table and the vise, so I'll get this mounted and trammed as well. It's a little crowded, but I think this will work fine. Okay, now for stage 2. I'm going to need a way to accurately hold and locate the wallet at the center of the rotary table, which means I'll need a fixture plate. It just so happens that I have some 5083 aluminum tooling plate that would be perfect for this. My understanding is that this material has been stress relieved and precision ground, which should mean it will be very dimensionally stable during machining. Probably not absolutely necessary for what I'm doing here, but I've got it, so why not? After milling the sides all square, I can move on to drilling and reaming the various holes that will help me locate this plate on the rotary table. The locations of these holes will make sense shortly. Next, I can mill the pocket that will locate my brass blank. You'll notice the direction I'm milling as I cut the perimeter. This is in effect Klein milling and will prevent me from inadvertently overshooting my dimensions as the tool flexes. I'll hog the middle out with the conventional milling method, and then skim the perimeter once more to take it to the final size. Then that takes care of the fixture plate. Now I just need a way to locate this on the table itself. This will probably be the only lathe work I'll see on this project, so I'm going to cherish it while it lasts. I'll turn down the OD of the slug to match the bore of the table. Then turn the end down further to a pin that matches the reamed holes in the fixture plate. After parting it off, I can flip this around, grabbing it by the pin and seating it against the chuck jaws so I can face it to length. Then that's it on this machine. So long for now, my friend. The pin is a perfect fit into the table, and the fixture plate is a perfect fit onto the pin. Maybe now I can actually get started on what I came here for. I'll spare you the lengthy detail of preparing the brass blank, as it looks eerily similar to preparing the aluminum tooling plate. The only difference this time around was that, in order to achieve a better surface finish, I side milled all 4 edges to dimension. So, let's see how it fits. Absolutely no play at all with the fixture plate. Just as I hoped. Now the time has finally come that I can explain why all this setup is important. This fixture plate will serve 2 purposes. One is to locate my brass blanks so that I can accurately cut all the corner fillets by spinning the rotary table, hence the holes near the perimeter. And second is to locate the brass blank about the central point of the engraved pattern. By doing this, I can cut all the lines in one direction, rotate the table 60 degrees to cut the lines in the next direction, and so on. The central pivot hole isn't absolutely necessary for this, but it makes the math a heck of a lot easier to keep track of. Well, that is if it's in the right spot. I just noticed I have this hole in the wrong location. I guess that's what I get for not putting together a proper drawing for this thing. 1 second. Yeah, this drill's not liking being that close to the first hole. I should have known that would happen. Hopefully this end mill will salvage this hole. It's a little cattywampus, but as long as I favor it against the top right, it will work okay. Especially for a one-time use fixture like this. Let's get everything in place. The first step is to locate the center of the rotary table with a coaxial indicator. And once there, zero both axes on the DRO. Now I can position the fixture plate with the centering pin and use a combination square to align it with the table. And then clamp it down with the T-slot hardware. Ugh, really? The shortest stud I have is, annoyingly, just slightly too long. These side projects are really coming in force today. At this rate, I might actually get to the meat of this build sometime next year. I could cut some sheet stock to put under the clamp, but this isn't the first time I've run into this issue. But rather than kill any more time on some elaborate custom machined studs, I'll make this speedy and just lop off some lengths of some carriage bolts I found laying around. It's not pretty, but it works. Moving on. The combination square got my fixture plate pretty well aligned, but a lot is going to depend on the position of this plate. To get it as close as possible, I'll set up the dial indicator and tap it in the rest of the way while sweeping the front face. I'm going to start engraving and there will be a metric ton of lines to keep track of, so I'll keep the drawing nearby, and to make it just a little bit easier to see, I'll coat the plate in some layout fluid before clamping it down. The engraving bit I ordered is a 60-degree single flute with a 15 thou radius. And based on the proper speeds and feeds for brass, I should be running this in excess of 15,000 RPM, which just isn't happening on this mill. I'll run it as fast as I can though and hope for the best. I'll set the quill stop for a 10 thou depth of cut and I think that's it. Time to actually do this. Well, that first pass looks beautiful, especially with the gold against the blue. I have a feeling this is going to be very visually stimulating, so let's keep going. I'll index the table to the left and start the process of cutting all the vertical lines. It's not super easy to follow the pattern at this point, but it should start to reveal itself soon. Once I clear the right side of the part, I can reposition the clamp. Then start on the left side and work my way back to the center. That already looks so cool, and I'm only a third of the way complete. To cut the next set of lines, I'll rotate the table 60 degrees. Then start working my way across the plate once again. At this point, I'm rapidly becoming thankful for the math I put into this hex pattern ahead of time. I knew most of my hand wheel movements were going to be in the y-axis, so I sized the geometry such that all my start and stop locations end up being even numbers, making this a heck of a lot easier to keep track of. After rotating the table another 60 degrees to cut the final set of lines, the pattern suddenly starts to emerge. It really is satisfying how, as I start and stop each segment, the vertices of all 3 coordinate systems just line up perfectly, and it's highlighted even more by the beautiful golden pattern shining through the royal blue surface. After 2 hours of engraving, the pattern is complete. 1 second. As I was saying, after 2 hours and 2 minutes, the pattern is complete. And it already looks spectacular. Part of me wishes I could somehow keep this blue, but I have a feeling it will look even better all gold. Before dismounting this part though, I have a couple more operations to do in this setup. I still need to cut the mounting pocket for the money clip. The brushed stainless steel stock I had on hand was about a 32nd of an inch thick, so that will define the depth of the mounting pocket. With the rotary table turned back to 0 degrees, I can hog out this section. Again using the Klein milling method around the perimeter, and then conventional milling away the middle material. That actually looks pretty cool. Shame it'll be covered up when I install the clip. But at least I'll know it's there. The money clip is attached with two number 256 screws, so I'll go ahead and drill the pilot holes for these while I'm here, and then that's it for this side. While I still think the blue-gold contrast looks very cool, I'm super interested to see what it looks like underneath. Oh yeah, that's just sick. I'm really starting to get excited to see this thing complete, so let's keep trucking along. The 256 screws that attach the clip are minuscule by some standards, and of course the tap is equally as tiny. So I have to be extra delicate while cutting these threads. That was not delicate. In a strange twist of fate, just as I was thinking I created a whole lot more work for myself, I noticed the tap broke off slightly above the surface of the brass, leaving just enough for me to grip onto with some needle nose pliers. What a small but huge blessing. Alright muscles, let's try this again, but remember, turn it down a notch. There you go. Good save. Back to the mill. Next are a couple edge operations in the vise. To cut the finger relief whatchamacallit, I'm using this insert chamfer mill. I find myself using and designing around this tool in many of my projects, and I think it's because it has the ability to kill two birds with one stone. It mills and chamfers simultaneously, leaving a seamless result. Flipping the part 180 degrees in the vise, I can mill the edge relief for the money clip. Then it's back to the rotary table. This time pattern side down, so I can start hogging out the bulk of the material to form the card pocket. Once again, like all the previous pocket milling operations, I'm starting with the perimeter in a Klein milling fashion, then working my way towards the center as I remove the remaining material in a conventional milling manner. And yes, I did calculate the coordinates of each pass so I could produce a nice symmetric surface pattern. I know it's not going to be visible, but that doesn't mean it can't look good in hiding. After also milling the final clip relief, I can dismount this and start on the next setup. Well, actually, that's not looking so good now that I'm seeing it up close. The finish is nice around the edges, but it really starts to get gnarly in the middle. I think I know what's going on here though. As I milled closer and closer to the center, my supporting material got weaker and weaker, allowing it to succumb to the forces of the end mill. I seem to have overlooked the first three rules of machining: rigidity, rigidity, and rigidity. On the bright side, I have some extra thickness to play with here, so I'll set this back up and take another 10 thou off the depth of the pocket. This time around holding the middle down until I run out of clamp clearance, then repositioning the clamps from the outside and supporting as close as possible to the center while I finish it out. If I were to do this again, the solution would be to start in the middle and work my way out to the edges. Alright, that's more like it. And that brings me to the final bit of machining on this part: the fillets. As I mentioned before, that's what these other holes in the fixture plate are for. So I'll get this set up around one of the lower holes and true it up to the table using a combination square like before. But this time around I'll skip the precision indicating. I think this will be more than accurate enough for these small cosmetic features. After clamping the part in the fixture, I can bring the end mill in until it's just nearly touching the edge, then sweep the rotary table through a 90-degree rotation to cut a nice little fillet. Yup, that's about as good as I could have hoped for. From here I can start flipping and milling the remaining three corners. I realize how silly it is to be using this massive 12-inch rotary table to cut a meager 1/8-inch radius fillet. Talk about overkill. But it's what I have, and it gets the job done. There are still two more fillets to take care of on the ends of the sidewalls, and that's what the final two fixture plate holes are for. I'll get this set up in the same manner as before, then bring the end mill in and sweep the table through a 180-degree rotation this time to form these as well. And as luck would have it, on the very last operation, I ended up just barely touching the finish on one side. While I'm not thrilled about this, it will be mostly hidden behind the contents of the wallet. So I'm going to make one small exception and let it slide. Other than that, this is looking great. But at this point, it's nothing more than a fancy piece of brass. It won't be very useful without the second piece of the puzzle, the clip. I'll start by chopping the brushed stainless stock I have down to a more manageable size. Then also make this narrower with the belt grinder until it's a consistent dimension and a nice fit in the pocket of the brass body. To match the internal fillets, I'll loosely grind these on the belt grinder as well, but then switch to some emery cloth for the finer radius work until it's a dead match. Beautiful. With the clip in position, I'll transfer the two mounting hole locations with a small drill bit, center punch the faint scribings left behind, and finally drill the two clearance holes. The only 256 screws I have on hand are much longer than I need, so I'll carefully trim these down with a die grinder, and then put this all together. Oh yeah, I'm really liking where this is going. I originally had plans to come up with some clever fixture for bending the clip into its final shape, but then I realized I already have the perfect fixture made. I can bend this over while mounted right here to the wallet body. Then, setting this up in the vise, I can use a soft hammer and punches to bring the back of the clip flush with the wallet. The top side of the clip gets a more gradual bend that I can form by wrapping around the shaft of a transfer punch. Then the final upward bend at the end of the clip is formed in a similar manner. I'll chop the excess length off the end, grind a nice radius on the leading edge, and then put the final touches on it with some emery cloth. And while I'm at it, do the finish sanding on the brass body as well. Alright, let's put this bad boy together. Oh yeah, that looks freaking nice. But how does it work? Perfectly, that's how. Easily has capacity for 5 cards, plus a little extra room for cash. And it's all held quite securely. Excellent. Now, it's time I let you in on a little secret I've been keeping. I actually already have a low-profile wallet. My wife got me this one years ago as a college graduation present. And while an upgrade isn't off the table, I didn't make this one for myself. I actually made it for my brother. It's just missing one last detail. Perfect. So if you're watching this, Jake, happy early birthday. Now that's truly it for this wallet. I'm so pleased with how it turned out. The combination of the yellow brass, silver steel, and black screws just looks so good together. And the pattern looks really sharp without being too much. Not everything in life has to be completely minimal, but having a simple, clean, good-looking wallet is a real treat for anyone looking to streamline a bit. And I hope my brother enjoys this one for years to come. As always, thanks for watching, and see you next time.